Hello dear students, welcome back to Learn Physics. In last class we were discussing about laws of motion and the continuation of that, which is the different forces acting on the object. So in that first question we already discussed. Now we are moving to the second question. Second question also I just told you the forces acting on the sphere A and B. First, I am considering for the sphere A. When I am considering the sphere A, weight is acting exactly downwards. So, weight acting mg, that is acting exactly downwards. And here, at this point, it is in touch with the wall, right? So, here a reactional force will be acting by the wall. Here, a reactional force will be giving outward direction, and here you can see a ball B here. That ball will be giving a weight W downwards. W will be a weight which is acting downwards, and the reactional forces will be here a N, a reactional force which is acting towards this direction, and here another one, a reactional force will be acting in this direction too. Okay, so here this force and this force will be the same, equal and opposite reactional force. And here B is in touch with this wall, right? So here also a reactional force will be acting towards the N. Another force will be acting towards B. Okay, so towards B one force is acting. So in B we are getting mainly three forces, that is mg which is acting downwards, and the reaction which we are getting from this one. So the reactional force which I am giving us, see here this one and this force, both are equal forces. Okay, here another force n1, another force is acting in this direction, other force is acting in this direction. So this one won't be cancelling each other, but here we will be getting two forces. And one more force we forgot, that is a reactional force which will be getting by this side. Okay, so from the ground a reactional force is acting. So for the second question I am explaining it once more. This is the sphere A. For the sphere A we are getting a downward force mg towards the ground. So the ground will be giving a reactional force, normal reactional force in the upward direction. Now this wall will be giving a reactional force, because here against mg which and all forces will be there. Normal reactional force will be acting in from the wall to A. Okay, so another force which is acting here, this one I am representing this as N1, and here normal reactional force N2. Now I am considering for the sphere B. Actually this B is in touch with A. So B will be, for B, mg will be acting downwards. Mass of B into G. And for that, reactional force, in which direction it will be acting? It will be acting in towards A, because it is acting in the opposite direction. So at the same time, A will be acting a reactional force in the opposite direction. Right? So I am marking this as N3. These two forces will be equal and opposite. Okay, and from here, see here you can see a wall, right? The wall will be giving a force in the opposite direction. Exactly, normal reactional force. We told it in the Hinge Force. They are horizontal and vertical forces. But at the in the case of ladder, last class we explained for the ladder, when it is kept on the two walls, a normal reactional force will be acting on it. Both will be perpendicular to each other. That and all we learned in the previous class. So same kind of forces will be acting over here. Okay, this is the free body diagram for this forces. Okay, next we are moving to the third question. A point A on a sphere of weight W rests in contact with a smooth vertical wall and is supported by a string joining a point B on the sphere. So B is supported by a string, here it is on the wall, and sphere A is in contact with a smooth vertical wall. It is in contact with the vertical wall only. and draw the free body diagram of the sphere. So I'll redraw this diagram over here down. Okay. So here I'm going to draw the same diagram first. Okay. So same diagram I'm going to redraw it over here. This is a wall and it is vertically attached to the sphere A at the point. This is the point A and B is attached through a string towards the point C. Okay, so here we need to find out we need to draw the free body diagram of the sphere. The point A on the sphere, weight W rests in contact with a smooth vertical wall and is supported by a string joining a point B on the sphere to a point C. So which are the forces acting on it? Can you see here? Mg, which is acting downward direction, and then next is here it is in touch with this one, right? So a normal reactional force will be acting over here, and through the string when it is acting, a tension will be acting in the other side. Okay, this is the tension which is acting on the wall through the string. Okay, so Mg is acting downwards, then N is acting, normal reactional force is acting like this, and the tension will be, this is the free body diagram for that one. Okay, next we are moving to the next one, that is fourth one. A rod AB of weight W1 is placed over a sphere of weight W2. So this has weight W1 and this has weight W2. Ground is rough and there is no friction between the rod and the sphere and the wall. Between the rod and the sphere there is no friction, and between the sphere and the wall also no friction. We need to draw the free body diagram. So I'm going to redraw the picture over here. This is the wall and this is ground. Okay, this is the wall and this is ground. Here the sphere is kept over here like this, and here a rod also here. Okay, and this is A, this is B, and this is C. Now we need to find out which and all forces is acting. Here I'll consider that separately as we did in the previous case. So first I am going to consider for the sphere. Sphere weight W2 is acting, right? A sphere of W2 and rod W1. So W2 I am representing for weight here. And it is in touch with this point, right? It is in touch with the wall. There a normal reactional force will be acting by the, a normal reactional force will be acting from the wall towards the rod. Okay, normal reactional force will be acting from the sphere towards the wall. Now a reactional force will be, normal reactional forces acting in the upward direction too. Now I am considering for the rod. For the rod, a weight W1 is acting here, and how much of a force it is acting towards it, that much it will be reactional force from the rod, right? Because rod will be acting a force on the sphere. So if I am giving this force as N1, this also, the reactional force which is acting on it also will be N1 only. And here we are getting it as N2, which is acting at the reactional force. Now W1 is acting on the rod, it is downwards. N1 is the reactional force which we are getting from the sphere to the rod and rod to the sphere, same force. Now next is, we need to consider for whether should we consider about the friction. No friction between the rod and the sphere. Sphere and the rod, no friction. And so next is no friction between rod and sphere. Rod and sphere, sphere and wall also no friction. But rod and the ground friction will be there, right? So that friction we need to mark it over here. Rod and the ground friction will be there. Okay, and for this W1 will be getting a reactional force. So a reactional force will be acting like this. That one I'm representing it as N3. So here this is the N3 which is getting the reactional force, and here N1 which is equal and opposite, and N2 is acting in the opposite direction. And now we need to get a reactional force from this wall to the sphere, right? That wall to the sphere reactional force is N4. Okay, for this sphere when we are considering, I'm going to draw, tell you once more about the force which is getting for which and all forces will be acting on this one. First, I am going to consider for the sphere. For the sphere, the forces acting as mg will be acting like this, and the wall will be giving a force to the sphere. Wall, when it is giving the force to the sphere, it will be like this. And now reactional force from the sphere. Okay, this is the reactional force which is acting. So mg, it is given as m2 w2 here in the question itself. So I am representing it's this W2 will be having a reactional force. I am representing it as N2, and the reactional force which is getting over here is N1 I am marking. Okay, here I marked it as N4. Okay, N4 I am marking here also. Now I am considering if the rod is not there, this many forces will be acting on this sphere. Now if I am considering the rod alone, when I am considering W1 is acting downwards, a reactional force will be acting on the rod in the opposite direction, which I am marking as N3, and ground and the rod will be having a frictional force. There is no frictional force between the rod and the sphere and the wall. So there is a chance for sphere and the ground as well as the sphere, the rod and the ground. Right? So the friction between the rod and the ground and the friction between the sphere and the ground is marking in the opposite directions. Now, next is a force, a reactional force between sphere and the rod. So, a reactional force between the sphere and the rod. See here I am marking it as N1 here, and on the rod also a reaction from the sphere, same reactional force from the sphere to the rod. Okay, clear? These are the different forces acting on it. Now, next we are going to consider for this fifth question. Okay, so I'm moving to the fifth question. First, I'll copy the questions over here. So, children, these are the questions. So here, a rod OA is suspended with the help of a massless string AB as shown in figure. Rod is hinged at the point O. Free body diagram for the rod. Okay, so here we have a rod and which is attached to a string to the wall. Okay, this is already supported with another wall. The points are A here, B here, and here this is O. Okay, so here at the point O, there is a hinge force which will be acting. Okay, for this hinge force, usually we will be considering it as horizontal force as well as the vertical force. Last class I told you horizontal force solving method is will be considering as a horizontal force and vertical force. So here I can consider at the hinge horizontal force in this direction and vertical force at this point. Okay, how to solve these questions we will be discussing that in the coming days. Okay, now a force of this is a rod, so this rod is having rod is having a weight in the downward direction, so weight will be acting downward direction, and this is AB is the string. Through the string, tension will be acting on the string. Okay, T. So these are the forces which is acting on this rod. So the here forces, horizontal force, vertical force. These are the hinge forces acting on the rod, and tension through the string, tension will be acting. Now, for the sixth question, we are considering the sixth question, that is, a rod AB is placed inside a rough spherical shell as shown in figure 8.45. Draw the free body diagram of the rod. So, inside the sphere, a rod AB is kept. A rod AB is kept inside the sphere. So, how can we find out which and all forces will be there? See, here for this rod will be free body diagram of the rod only it's required, not for the sphere. So, for rod, a weight will be acting downward direction, and here it is in touch with these 2 points, right? So, here it will be acting a force in the towards normal reactional force, and from here also another normal reactional force will be acting. Normal reaction at the point B. At the point B, how the normal reactional force will be acting? Is it through the rod? Normal reactional force. Normal reaction will be acting through the normal, right? So it will be acting like this. To the point, that is for that tangent, it will be normal. Okay, this is the tangent which is acting over here. So normal to that tangent will be at. So for the point A also, normal reactional force, it will be acting normal to that tangent. So at the point B and A, we will be getting a normal reactional force, that is normal to that point. So if we are drawing a tangent at the point B and A, we can draw the two normals like this. Now, next here they are not telling anything about the frictional force. So, frictional force between force of friction will be there for the point A as well as B. If the object is moving in this direction, frictional force will be acting in the opposite direction, and here it is moving in this direction, so the frictional force is acting in the opposite direction. So, this is F1 and F2. These are the major forces which is acting on the rod which is kept inside the spherical shell. Okay, so mg will be acting downwards, normal reactional force will be acting normal to that. Okay, normal to the sphere. Okay, clear children? So these are the important points about the free body diagram. In next class, about in equilibrium position, how we will be dividing the force into its components, that and all we will be learning. Okay children, so I hope today's video is useful for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.